This video is in response to a question from the Chapter 5 review. And the question is this. We're given a graph over here on the far right-hand side, and we're asked to write the equation for this graph that's shown. Okay. Now, in doing so, we're asked to write it either in terms of a sine curve or a cosine curve, and then simplify our answer. Leave it in exact form. So to begin with, I'd like to review with you the different things that we need to look for here. One is we have to choose between a sine and a cosine curve. Now, when I look at the graph that's given, what I notice here is that the curve goes through the origin. So we think about that. Which one, sine or cosine, passes through the origin? And of course, the sine curve does. And so we're going to use that. If the graph is reflection about the x-axis, the leading coefficient will be negative. Well, we also know that basically what a sine curve looks like, let's see if I can do a quick sketch here, is something like this, whose amplitude is 1. And the period is 2 pi. That's from pi, negative pi, rather, 2 pi. And we complete one cycle for that. So here it looks something like this. It's just a rough sketch. Pretty rough. But anyway, that's one cycle of the sine curve. So as we're looking at this curve that's given, it is definitely flipped about the x-axis. So that means our leading coefficient is going to be negative. Another feature is the amplitude. Now, the amplitude is that stretch, that vertical stretch. So in this case, as I'm looking at this, it looks like it stretches from a -4 here up to a +4. Well, typically it's 1. 1 is the amplitude for y equals the sine of x. So here our stretch is going to be 4. So we already know a couple of things about this curve. So we know that this is going to be y equals -4 because it's flipped, stretched 4. And we're going to use the sine. So this is the sine. So now we need to find omega. And to find that coefficient for the x here, what we're going to do is identify the period from the graph. Now, the period here in the graph looks like it goes from about, -3 to, well, beyond a +3. Let's do some counting here. Maybe we could start at this point and have one cycle go from this point here at the origin to this point, and that looks like that's 3, 4, 5, 6, 7 units. So the length of one cycle is 7. Well, that's the t. So to do that, that means now our value for omega is going to be 2 pi divided by t, which was that 7. So now we've got 2 pi divided by 7, and that's with the x. So that should be the equation for this graph that we see.